minus x squared over x plus 2. First part, it is required to determine the domain of definition. To determine the domain of definition, since it is a rational function, so we take its denominator. The denominator is x plus 2. So we say x plus 2 not equal to 0, x not equal minus 2. So we write the domain in the form of interval, which is minus infinity to minus 2, union minus 2 plus infinity. So to determine the domain of definition of a rational function, we take its denominator. The denominator should be different from 0. Now, second part, we are going to determine the limit at the open bounds of the domain. We have 4 open bounds, which are minus infinity, minus 2, plus, and plus infinity. First of all, let's determine the limit as x tends to minus infinity. Limit as x tends to minus infinity, since it is a rational function, we take the highest degree of the numerator over the highest degree of the denominator. So we get minus x squared over x. We simplify x with x remains minus x, as x tends to minus infinity. Minus times minus infinity, we get plus infinity. The second open boundary is limit fx as x tends to plus infinity. Also limit as x tends to plus infinity, we take the limit of the highest degree over highest degree, we get minus x squared over x. If we simplify, we get minus x, then we replace x by plus infinity. Minus times the plus infinity, we get minus infinity. The third open boundary is x tends to minus 2 minus. Limit fx as x tends to minus 2 minus. We replace x by minus 2. We don't take the highest degree, only we replace x by minus 2. If we replace x by minus 2, we get minus 4 plus 9 over minus 2 plus 2. We get 5 over 0 minus, which is minus infinity. Once again, we replace x by minus 2. We get minus 4 plus 9 over minus 2 plus 2. We get minus infinity. Limit as x tends to minus 2 plus of fx equals minus 4 plus 9 over minus 2 plus 2. We get 5 over 0 plus, which is plus infinity. So whenever we are going to determine the limit at a number, we replace x by a number. So number over 0 is either plus infinity or minus infinity. Now we are going to deduce an asymptote. We remind you that we have 3 types of asymptotes: vertical, horizontal, and oblique. Since he said deduce, from the above limits we get x tends to minus 2, y tends to plus or minus infinity. This is the definition of the vertical asymptote. So x equal minus 2 is a vertical asymptote. X equal minus 2 is a vertical asymptote. So from the above limits, since x tends to minus 2, y tends to plus infinity, then x equal minus 2 is a vertical asymptote. Here x is a number while y is infinity. So we say x equal minus 2 is a vertical asymptote. 3. Part A. Calculate the derivative f prime x. We are going to determine the derivative f prime x. We have fx is of the form of a ratio u over v. Fx is u over v. U equals minus x squared plus 9. The derivative of minus x squared is minus 2x. The power, we put the power down and we reduce the power by 1, minus 2x. And the power of 9, since 9 is a constant, the power of 9 is 0. V equals x plus 2, V prime equal 1. Derivative of x is 1, while the derivative of 2 is a constant, it is 0. Then we apply the rule of u over v, the derivative of u over v, which is u prime v minus v prime u over v square. So the derivative is u prime v minus v prime u over v square. U prime is minus 2x, v prime is x plus 2, minus v prime is 1, and u is minus x squared plus 9 over v squared x plus 2 squared. So we expand. Minus 2x times x is minus 2x squared, minus 2x times 2 is minus 4x, minus 1 times minus x squared is plus x squared, and minus 1 times minus times plus 9 is minus 9 over x plus 2 squared. Not necessary to expand x plus 2 squared, we leave it as x plus 2 squared. So f prime x, after reducing, minus 2x squared plus x squared is minus x squared, minus 4x, and minus 9 over x plus 2 squared. So since it is a rational function of the form u over v, derivative is u prime v minus v prime u over v squared. We find u prime alone, we find v prime alone, and then we apply the rule. So we get f prime x minus x squared minus 4x plus 9. So f prime takes the sign of minus x squared minus 4x minus 9, since it is the numerator. Since the denominator is positive, since x plus 2 squared is positive, then f prime takes the sign of the numerator, which is minus x squared minus 4x minus 9. Now we are going to verify or to show that f is strictly decreasing. We need to verify that f is strictly decreasing. To verify that a function is decreasing, we have to show that its derivative is less than 0. So f is decreasing if its derivative is 0, is less than 0, while the function is increasing if f prime x is positive. Here we are going to show that f is decreasing. It means that f prime x less than 0. This is we are going to show. So we solve f prime x equal to 0. So the numerator, which is minus x squared minus 4x minus 9 equal to 0. Since it is of the second degree, we find delta. Delta is b squared minus 4ac. B is minus 4 squared minus 4. A is minus 1, the coefficient of x squared, and c is minus 9. So we get 4 squared is 16, and minus 4 times minus 1 times minus 9 is minus 36. So delta is negative. Delta is negative. We know that we have no real roots. We are interested in the sign of the derivative. Since delta is negative, f prime x takes the same sign as a. A is minus 1 from here, from minus x squared minus 4x minus 9. A is minus 1. So f prime x is less than 0 for every x belongs to the domain of definition. Also, if we are not going to solve using delta, we can solve this equation minus x squared minus 4x minus 9 by using the calculator. If we use the calculator will give two complex roots in it. The calculator will give I in the solution. Whenever the calculator gives I in the solution, means we have no real roots, and f prime x will take the same sign as x. Now we go to part B, which is table of variations. Table of variations, uh, part B, since f prime x is less than 0, so table of variations of f, since f prime x less than 0, so it is always negative. Remind that always we have to put on the number line, which is x, the domain of definition, minus infinity, minus 2. Don't forget that to put minus 2 from the domain of definition, plus infinity. On the first line, we put f prime x, on the second line, fx. So x, f prime x, fx. Negative, negative, since we have proved in the part A that f prime x less than 0. Negative, it is decreasing. Negative, it is decreasing. Now, to find the values here, as x tends to minus infinity, we go back as x tends to minus infinity. It is minus infinity, it is plus infinity, so we put here plus infinity. As x tends to plus infinity, we go back to the limits. As x tends to plus infinity, also we get minus infinity. As x tends to minus 2 minus, we get minus infinity. We have a vertical asymptote. And as x tends to minus 2 plus, we get plus infinity. So once again, table of variation, we have to put the domain of definition, the sign of f prime, which is always negative, negative, negative. We put decreasing, decreasing. So negative, negative, since f prime x is negative from here. F prime x is negative for every x belongs to the domain of definition. So this is all about part variations and table of variation. Now we start with part 4. Calculate. We need to calculate A, B, and C if. So the question is calculate A, B, and C if fx is written in the form ax plus b plus c over x plus 2. So we are going to calculate A, B, and C if fx equals ax plus b plus c over x plus 2. I put fx, the given value, which is minus x squared plus 2 over x plus 2. We replace fx by its value here. This is given fx minus x squared plus 9 over x plus 2. And this one is ax plus b plus c over x plus 2. I put it over 1. I take the LCM on the right side. On the left side remains the same, minus x squared plus 9 over x plus 2 equals, LCM is x plus 2, x plus 2 over 1 is x plus 2 times ax plus b plus c. Since we have x plus 2 on the two sides, I can skip x plus 2 with x plus 2. While in the above line, I cannot skip x plus 2 and x plus 2 because ax plus b, it is not over x plus 2. Now I expand the right side. Minus x squared plus 9 equals ax squared, ax times x, ax squared, ax times 2, 2ax, plus bx, plus 2b, plus c. Then we reduce. Ax squared remains ax squared. 2ax plus bx. To add them, I take x common. I cannot add a with b, so I take x common, remains 2a plus b plus 2b plus c. Now I will repeat. So we need to calculate a, b, and c if fx equal ax plus b plus c over x plus 2. We replace fx by its value, and the second side remains ax plus b. I put it over 1 plus c over x plus 2. We take the LCM, which is x plus 2 on the right side. x plus 2 over 1 is x plus 2 multiplied by ax plus b plus c. X plus 2, I remove x plus 2 and x plus 2 from the two sides. We expand, then we reduce. Reducing, we add x squared together. X, we have two terms that contain x, 2a plus b plus 2b plus c. By the method of identical polynomials or by comparison, the coefficient of x squared on the two sides should be equal. On the left side we have minus x squared, and on the right side we have ax squared. By comparing, we remove x squared and x squared, we get a equals minus 1. So by comparing, the coefficient of x squared on the left side should be equal coefficient of x squared on the second side. So minus x squared equal ax squared, so a equal minus 1. Coefficient of x now should be equal on the two sides. On the right side I have 2a plus b. On the left side here I don't have x, so the coefficient of x is equal 0. So coefficient of x equal coefficient of x, 2a plus b on this side equals 9 on the other side. So 2a plus b equal to 0. We replace a by its value, which is minus 1. 2 into minus 1 plus b equal to 0, then b equals to 2. Now constant equal constant. The constant on the right side is 2b plus c, and the constant on the other side is 9. So we say 2b plus c equals 9. B is determined, we find b equals 2. So 2 times 2 plus c, 4 plus c equal 9, and c will be equal 9 minus 4, which is equal 5. Okay, I will repeat. So we are going to determine a, b, and c if fx equal ax plus b plus c over x plus 2. Fx is replaced by its value, ax plus b plus c over x plus 2. We take the LCM on the right side, which is x plus 2, then x plus 2 divided by 1. We get ax plus b into x plus 2 plus c. We remove x plus 2 from the two sides. Then we expand, then we reduce. We collect x squared together, x together, and the constant together. By comparing the two sides, the coefficient of x squared on the two sides should be equal. So we get a equal minus 1. The coefficient of x on the two sides should be equal, means 2a plus b equals 0, because we don't have x on the left side. So by replacing a by minus 1, we get b equal 2. And the constant number equal to the constant number. On the right side, the constant is 2b plus c. On the right side, the constant is 9. So, and b is determined, which is 2. We replace b by 2, and we get c equals 5. So, f as a conclusion, fx equal ax plus b plus c over x plus 2. A is minus 1, so we get minus x. B is 2, we get plus 2. And c is 5, we get 5 over x plus 2. So fx equal minus x plus 2 plus 5 over x plus 2. This 4 help us to calculate the equation of the oblique asymptote. So we have written this one in part 4a in order to determine the equation of the oblique asymptote. Always, this constant, the minus x plus 2, will be the equation of the oblique asymptote. So equation of the oblique asymptote of A. In the exams, the equation will be given, but in this exercise, the equation is not given. I say let line D equal y equal minus x plus 2. As I said before, it is determined from here. Y equal minus x plus 2 plus 5 over x plus 2. I take not the fraction part, so it is minus x plus 2. So to prove this one is an oblique asymptote, I have to prove that according to the rule we took, to prove an oblique asymptote, we are going to show that limit fx minus yd as x tends to plus or minus infinity should be 0. To prove we have an oblique asymptote, we have to prove that limit as x tends to plus or minus infinity fx minus yd equals 0. So fx, it is better to use this form of fx. In this form we are not going to take the common denominator, so it is easier to take this form if it is given. If it is not given, I use the fx from the first part, but since this one form is given, it is better to use this form, minus x plus 2 plus 5 over x plus 2 minus yd, which is minus x plus 2 minus x plus 2 minus into minus x plus 2, they cancel, remains 5 over x plus 2, limit as x tends to plus or minus infinity. We remove the limit, we get 5 over plus or minus infinity, which is 0. From this we deduce that the line D of equation y equal minus x plus 2 is an oblique asymptote to C. So to determine the equation of the oblique asymptote, so from the part A, since fx is written in that form, this form minus x plus 2 will be the value of the oblique asymptote. So I say line D y equal minus x plus 2. So the definition of the oblique asymptote, limit fx as x tends to plus or minus infinity, fx minus yd should be 0. This is fx minus yd minus x plus 2 minus into minus x plus 2, 0. They simplify. 5 over x plus 2 as a limit as x tends to plus or minus infinity. We get 5 over plus or minus infinity, which is 0. Therefore, the line dy equal minus x plus 2 is an oblique asymptote to C at plus or minus infinity. Part 5, it is required to determine C intersection the coordinate axis. The coordinate axis means the x-axis, which is called the abscissa axis, and the y-axis, which is called the coordinate axis. So C intersection the ordinate axis, C intersection the y-axis. We are going to check where the curve cuts the y-axis. Since every point on the y-axis, has an abscissa 0, so x equal to 0. Once again, to determine the intersection with the coordinate axis means both axes, x-axis and y-axis. C intersection y-axis, on the y-axis x0, I replace x by 0, we get y equal 9 over 2, and I get the point 0, 9 over 2. This is the point where C cuts the y-axis. By the same way, C intersection x-axis, to find the intersection with the x-axis, every point on the x-axis, y should be 0. Is y 0? Then minus x squared plus 9 over x plus 2 equals 0. Cross multiplication, we get minus x squared plus 9 equal to 0. Minus x squared equal minus 9. Then x squared equal 9. And x equal plus or minus 3. So we get 2 points of intersection with the abscissa axis, which are minus 3, 0 and 3, 0. So to determine C intersection coordinate axis means the y-axis and the x-axis. With the y-axis we take x equals 0 and we find y. With the x-axis we find y, we take y0 and we find x. Now the equation of the tangent to the curve at point of abscissa 2. So we are going to determine the equation of the tangent, part 6. Equation of the tangent to C at xa equal to. Tangent as a rule, rule of that equation of the tangent, y minus ya equal f prime of xa. F prime of xa is the slope into x minus xa. This is a rule to be memorized. Y minus ya equal f prime of xa into x minus xa. This is the equation of the tangent. Xa equal to. So first we have xa equal to. I need to determine ya. To determine ya, I replace the value of x in the given equation or in the given function. I get minus 4 plus 9 over 2 plus 2. We get 5 over 4. So point A becomes 2, 5 over 4. F prime of xa, it is f prime of 2, this is the slope. I replace the value of x in the derivative. We have the derivative, we have determined the derivative in first, we have determined the derivative, which is minus x squared minus 4x minus 9 over x plus 2. We replace x by 2, it becomes minus 4 minus 8 minus 9 over 2 plus 2. Replacing x by 2, which is xa, we get the value of the slope of the tangent. We get the value of the slope of the tangent, which is minus 21 over 16. Now, by replacing each one by its value, ya is determined 5 over 4. The slope is minus 21 over 16 into x minus 2. Now, by expand, we expand y minus 5 over 4 equal minus 21x over 16 plus 21 over 8. We bring minus 5 over 4 to this side plus 5 over 4. We take the LCM for 8 and 4, which is 8. We get minus 21x over 16 plus 31 over 8. So don't forget the equation of the tangent is y minus ya f prime of xa into x minus xa. Xa is given, so we have to determine ya and the slope, which is f prime of xa. Ya is determined by replacing x by its value in the equation or in the function, and the f prime of xa is determined by replacing the value of x in the derivative. Now part 7, we are going to show that I minus 2, 4 is a center of symmetry. I minus 2, 4 is a center of symmetry. As a rule we took last year, to prove center of symmetry, we are going to verify f of 2a minus x plus fx equal to b. f onto 2a minus x plus fx equal to b. a here is minus 2, I here a, b. In a is minus 2, b is 4. If we replace a by minus 2, 2 times minus 2 is minus 4, minus x remains minus x, plus fx equal 8. We are going to show that, therefore, a from here minus 2, b is 4, بتصير هون عنا 8. So we are going to verify this equation. F of minus 4 minus x plus fx equal 8. To verify this equality, it is better to use the fx, that 4. We can replace the given form of fx, but it is easier to use that 4. Fx equal minus x plus 2 plus 5 over x plus 2. It is easier to use this 4. F into minus 4 minus x. Each x in fx is replaced by minus 4 minus x. F of x is this one, f of minus 4x. This x is replaced by minus 4 minus x. 2 remains 2, 5 remains 5. This x here is replaced by minus 4 minus x plus 2. We remove the brackets. 4 plus x plus 2 plus 5 over minus x plus 2. 4 plus 2 is 6. X is x minus 5. Start minus x minus 2. I take minus here. From here it becomes minus into minus 5 into x plus 2. So f of minus 4 minus x is calculated by replacing each x by minus 4 minus x, removing the brackets, taking the minus from the denominator and putting it in the numerator, so minus 5 over x plus 2. Now f of minus 4 minus x plus fx equals f of minus 4 minus x, it is calculated here, minus x plus 2, and this is fx. This is f of minus 4 minus x, which is 6 plus x minus 5 over x plus 2. Okay, after reducing we get equals 8. So the equality is verified. F of 2a minus x plus fx equal to b. That is here f of minus 4 minus x plus fx equal 8. Then I is a center of symmetry. I is a center of symmetry for C. Finally, the last part. In the last part, we need to draw the graph. To draw the graph, first we have to draw the asymptotes. The first asymptote is x equal minus 2. This is x equal minus 2 is a vertical asymptote. To draw the oblique asymptote, which is y equal minus x plus 2, since it is an oblique line, to draw this line we need at least 2 particular points. So I take 2 points for x equal to 0, y equal 2, for x equal to, y equal to 0, and we draw this is an oblique asymptote. So we have drawn the asymptotes, vertical, oblique. If we go back to the table of variations, the table of variations, we notice that we don't have an extremums, maximum or minimum. So we have 2 branches. Since we have decreasing, we have 2 branches. The first branch is decreasing from minus infinity plus infinity till minus 2 minus infinity. It starts here and it goes down to minus 2 minus infinity. Here it starts from near the oblique asymptote and goes down near the vertical asymptote. While the second arrow, it starts from minus 2 plus infinity from near the vertical asymptote and goes down near the oblique asymptote. It is better to use your calculators, mode 7 in your calculator mode table. You take particular points, and so the first curve, and you take points. It is better, it is easier for you. شفنا points of intersection with the x-axis in the minus 3, 0. Second point is 3, 0. This is 3, 0. شفنا point of intersection with the y-axis is 0, 9 over 2, which is 5 over 4. So I can take more particular points. So the first part of the curve is decreasing from near the oblique asymptote. They always we start from the left. X minus infinity here. So the curve is near the oblique asymptote, decreases near the vertical asymptote. This is the first part. Then we have a jump. We start from the vertical asymptote here, and we go back and decreases. It passes by these points and goes near the oblique asymptote. Okay, this is all about this exercise. Please, if you have questions, you can ask next time. Write this exercise on your copybook